All right, so in this section, we will learn the object-oriented concept. First, we'll learn what is object-oriented programming concept. And then we'll learn the object and class. Then we'll learn the access modifiers. Then we'll learn some naming conventions. And we'll have a look at constructors. And then we'll play around with packages. And then we'll put together what is a static keyword and how the heck can I use it? And then we're going to cover nested and inner classes. So stick with me. This is going to be a bumpy ride. Object-oriented program, OOP, or OOP, is a method of designing and implementing software. So it covers a pretty broad range. But the primary purpose of object-oriented programming is to increase the flexibility and maintainability of programs. It simplifies the software development process and the maintenance process by providing some concepts. And these concepts are object, class, inheritance, polymorphism, abstraction, and encapsulation. So we're going to cover these subjects in detail in the upcoming slides. First, I want to start with the object-oriented concept. Object and class. So a class, it's a group of similar entities, right? An object can be defined as an instance of a class. So objects are often used to model real-world objects that you find in everyday life. A Java object is a self-contained component which consists of methods and properties. An object contains an address and takes up some space in memory. A class doesn't consume any memory space. So an object has three characteristics. It has a state, behavior, and an identity. So coming up in the next slide, we're going to try to understand the characteristics. Characteristics of object. So just as I promised, an object has three characteristics. It has a state, behavior, as well as identity. The state represents the data of an object. Now, the behavior represents the action of an object, such as start, stop, etc. Identity is used internally by the Java virtual machine to identify each object uniquely, right? So the value of ID is not visible to the external user. So let's think about maybe a car, and let's call it a Ferrari. The color is red. The model is 2015. These are the states, right? So this car starts and stops. So starting and stopping are behaviors. Object and class example. So let's make an example with objects and class. For instance, we define a car class, and the properties of an object car would be model, color, and year. An object also executes some actions. A car is capable of performing the following actions, right? Start, stop, and accelerate. Now, as you can see on the slide, for different values of properties, model, color, year, in the class car, we will get different car objects. So in our example, we have one class, but we also have three objects. Cool. Class declaration. Every Java application must have at least one class definition. A class is declared by use of the class keyword. The class body is enclosed between curly braces The data of the variables are defined in the class, and these variables are called instance variables. The action code is written in the method, and all code blocks are in the class body. So variables and methods are defined in the class, and these are members of the class. Creating an object. An object is created from a class. In Java, the new keyword is used to create new objects. And as you can see here in the slide, we created my car as an object from the car class by using the new keyword. So car, my car, equals new car. And here, my car, the object, is the reference which holds the memory address of the car object. So in this section, we will learn access modifiers in Java. Access modifiers are used for setting the access level to classes, variables, methods, and constructors. There are basically 4 access modifiers in Java. First one, of course, is default, by default. So that means that we will not explicitly declare an access modifier for a class, field, method, and constructor. A variable, method, and constructor declared without any access control modifier is available to any other class in the same package. The second one is public. Public access modifier is accessible from everywhere, and this is the least restrictive access modifier. And the third one is private. The private access modifier is accessible only within class. So methods, variables, and constructors that are declared private can only be accessed within the declared class itself. Private modifiers are the most restrictive access level. So the last one is protected. The protected access modifier is accessible only within the same package and in addition from all subclasses of its class. So in this part, you see the restrictive level of accessibility of modifiers. And as you see here in the slide, the most restrictive modifier is private, and the least restrictive modifier is public. Default comes after private, and protected comes after default. So in this section, we will learn naming convention rules in Java. Java naming convention is a rule to follow how to name your identifiers, like class, variable, method, etc. But it's not enforced. You don't have to follow it. It's known as a convention, so that means it's just a mandatory rule. Guideline, if you're a fan of Pirates of the Caribbean. Anyway, as you see here in the table, the class name should start with an uppercase letter and should be a noun. For example, string, car, system, etc. The method name should start with a lowercase letter and be a verb. For example, start, stop, action performed, etc. The variable name should start with a lowercase letter. For example, first name, year, color, etc. And then by using standard Java naming conventions, you can make your code easier to read for yourself and for other programmers. The readability of a Java program is very important. It indicates that less time is spent on how to understand what exactly the code does. The most important concepts of naming conventions are case-sensitive and camel casing. So Java is a case-sensitive language. For example, hello with the first letter as an uppercase and hello with the first letter as a lowercase are, well, they mean completely different things in Java. Camel casing is a naming convention in which the first letter of the second word in a compound word is capitalized. So you have a name that is combined with two words. The second word will start with uppercase letter always. For example, action performed, first name, etc. Constructors. A constructor is similar to a method. It has the same name as its class. And when a new object is created, at least one constructor will be invoked. Every class has a constructor that is named default constructor. However, constructors have no explicit return type. Now, as you can see in our example, a class can have more than one constructor. So in order to understand the working of a constructor, take this for an example. Let's say we have a class car, and when we create two objects of car, in creating the first object, the new keyword here creates the object of class car and invokes the default constructor, has no parameter to initialize the newly created object. And then in creating the second object, also the new keyword creates the object of class car and invokes the constructor that has one parameter to initialize the newly created object. So let's show you some visual examples about working with constructors. So first, let's create a new Java project. And we can specify the project name as object-oriented. Now don't bother changing the other options and just click the next button. So in this section, just uncheck the create module info.java file and then press the finish button. So in this project, just right-click on the source folder and select New Class. So specify the package name as OOP concept, OOP concept, and the class name is car. Okay, so we create a car class. The states of the car are model and current speed. We declare them as a private identifier because we cannot have access to these variables from another class. So now let's declare a public constructor that's named car, and it takes one parameter, and its name is model. So we declare the constructor as public because we want to be able to access this constructor from another class. So in the constructor method, we assign a parameter to own variable model. This keyword is used to access the same class members. Now don't worry, we will cover this as a keyword in the next slides. So let's declare 4 public methods of the car class. And we declare it as public because, of course, we want to have access to these methods from the other classes. Now, the name of the first method is start with void type. In the start method, we use the print method to display car has started as our message by adding the variable model. The name of the second method is accelerate. So we add 20 miles per hour to the current speed variable by using the add and assignment operator. And then the name of the third method is stop. So in the stop method, we use the print method to display the car has stopped message by adding the variable model. Also, we can set the current speed to 0 because if the car stops, then its speed, of course, is 0. Now, the name of the last method is showSpeed. And in the showSpeed method, we can use the print method to display the current speed of the car by adding the variable model and current speed. So let's save the code. All right, so we're going to need to test this class. So let's create a new class. Right-click on UpConcept package and select New Class. Specify the class name as CarTest, and then select the checkbox for the main method. So let's create the MyCar object by using the new keyword. So we pass Ferrari as a parameter to the car class. This process invokes a constructor having one argument. So let's call the methods by using the MyCar object. We can access the properties of an object with a simple dot notation. So if we write MyCar dot, Eclipse automatically brings the properties of class, and we can choose them to add to our code. So we add the start method first, and then accelerate, and then show speed, and then stop, and again, show speed. Okay, so let's run the code in the test class. So you see the results in the console right here. The start method is called and it displays the Ferrari has started message. The accelerate method is called and it sets 20 to the current speed variable. The show speed method is called and it displays the current speed of the Ferrari is 20. The stop method is called and it displays Ferrari has stopped and set 0 to the current speed variable. The show speed method is called again and it displays the current speed of the Ferrari is 0. Okay, so you are now ready to learn the toString method. Been waiting for this. So let's declare two variables in the car class. The first one is color with string type, and the second one is year with int type. So let's declare a constructor that's named car, and it takes 3 parameters: model, color, and year. All right, so in the constructor method, we can assign the model to its own variable model, color to its own variable color, and year to its own variable year by using the this keyword. So let's declare the toString method of the car class, and the toString method returns string. Now, we return name, color, and the year variables by using the plus operator in this method. So let's save the code. Okay, so let's pass the test class CarTest, and let's create a new object. So its name is MyCar1. Now we pass 3 parameters to the car class. They are Ferrari, red, and 2015. And now we add the object mycar1 to the print method. Now, if you print any object, the Java compiler internally invokes the toString method. So, let's run the test class again. And do you see the result in the last statement? Of course. The toString method is called and it prints model is Ferrari, color is red, and year is 2015. So let's open the car class, and we invoke this constructor and the toString method of the car class.